So if we're trying to approximate the sum of this series to within 10,000th, then what we need to know is that the error in making that approximation, call it R sub n, the remainder, is going to be less than the first term you omit. So B sub n is just going to be the absolute value of those terms, something like this. I want this term to be smaller than 1/10,000th. Or if you write it in scientific notation, that's going to be 1, 2, 3, 4. It's going to be 1 times 10 to the negative fourth. Now just FYI, you'll see that on your graphing calculator is e negative 4. Or maybe it'll put a 1e negative 4. That's what it's going to look like on a TI-84. So let's put that into our calculator and just try out values until we get down to the point that we've got something that's less than 1/10,000th. So I should have opened up my calculator. Oh, good. It is open up. All right. So let me clear out a couple things here. It doesn't really matter what your mode is in. I've got mine in function mode. So let's go to y equals here, and I'll clear out this stuff. Let's put in the equation. I'm going to use an x where I've got an n on my paper. So I've got an n here, but I'm going to use it as x squared over 10 to the x. So let's see, x and then the squared key divided by, you can do it a couple ways. You can do 10 to the x this way, or you can use the 10 to the x that's above the log. I don't know, it'll be really cool and do it above the log, right? Second, 10 to the x. There you go. So that's what I want. Enter that. Let's take a quick check to make sure our window settings are correct or our table settings are correct. So hit second and then window. Make sure that your independent is set to ask and your dependent is set to auto. That way you can choose the values of x. It'll come back with the values of y. From there, just go to the table. Second and then table. And then start trying some values until you find something smaller than 1/10,000th. And I happen to have a few values in here already. So 2 doesn't work, 3 doesn't work, 4 doesn't work. Does 5 work? No. It's not quite. Because it's 2.5 times 10 to the negative fourth. We need to be smaller than e negative 4. So the sixth term here is finally smaller than what we want, smaller than our 10,000th. So n equals 6 is the first term you can leave off. So n equals 6 is the first term you can leave off. And that means that your series will be within 1/10,000th of the actual value if you use the first 5 terms. So let's do that a couple different ways. I think the easiest way to do it is on Desmos. And let's see, I need a better one than that. So now to get a series, type in the word sum. S-U-M. And how cool is that? It sets you up right away. I want from 1 up to 5. And then I need to type in the equation. So it'd be negative 1 raised to the parenthesis n minus 1. And then n squared divided by 10 to the n. And bam, there you go. Pretty small. That's our total. 0.00015. So, okay. What about on a graphing calculator? Let's take a look at it there. Let me clear out of here. So I'll exit this. And let's clear this as well. Now I'm going to do two things. I'm going to create a sequence of all the terms, and then I need to sum up that sequence. So on the outside is going to go the sum, and on the inside is going to go the sequence. So let's start this way. I'll do second list, and then I want to go over to math.
You don't have to change the mode to sequence.
I'm hoping not. We'll find out. Find out if I have to change it to sequence. And from here I want sum. So I want the sum, and now I need to tell it, all right, let's generate the sequence that you're going to sum up. So we're going to go back to our list. This time go over to the ops. Or is it the math? Nope. Yeah, sequence. Yeah, 5. I was right the first time. So I thought I was wrong, but I was merely mistaken. All right. And now you can type in your expression. So -1 to the n minus 1. So I need to put that in parentheses. Now, I didn't put it in sequence mode, so it's okay. I'm just going to type in an x minus 1. And then I need an x squared in the numerator divided by 10 to the x. And I'll do it a different way this time. I'll just do 10 raised to the x instead of getting fancy like we did the last time. Your variable is x now, not n. Start at 1, go to 5. Step should be 1. And then we can paste that into our sum. So, wow, a lot going on there. A right parenthesis to close it off. Let me zoom back here so that you can see the full thing. So there it is, and there. Enter. Uh-oh.
I think the denominator might have to be in parentheses.
Shouldn't.
Because that's what mine was doing on my homework. If I didn't put the denominator in parentheses.
All right, let's try that. Second here. Boy, if I have to put parentheses in there every time, that'd be annoying.
Replace everything.
So if you want to insert something, you can hit the second key, then the insert key. It would help if I inserted something. Second, insert, parenthesis, and then parenthesis there. Go to. It doesn't like that. What don't you like about that? Oh. I gotta put a comma between these things. So insert, comma. All right, that should work. 0.06765. That doesn't match our decimals calculation. Did I type everything right for my decimals calculation? I think I did. -1 to the x minus 1, x squared, or 10 to the x. Let's look back at our decimals calculation. What's going wrong? There. Oh, I put 10 to the 5th. That should have been an n. There we go. Now they match. Whew. All right. Thank you. Yeah. Yeah. Show me your calculator during the break. I'll be happy to look at it.
I got this number, but with a negative. Okay.
The chances are you have the wrong exponent. Do you have x minus 1 in the exponent?
Yeah.
Yes? No?
Yes.
You do.
-1 x squared 10 to the
Okay. Yeah, you're going to have to take a look at it, or let me take a look at it during the break. But this one works. We've done it 2 different ways, and it works. So mission accomplished. I'm declaring victory and going home. All right, you can't go home yet, though. Any comments or questions on that one? I mean, it's a good problem to be able to do, is to find an approximation to that sum. And this is a good approximation. It should be good to, less than a 10,000th. That's pretty good. Comments, thoughts? Doing okay on that one? All right.